If you point a telescope at Jupiter, even a small one, you'll see it. A giant reddish oval swirling in the planet's southern hemisphere. It's called the Great Red Spot, and it's the most famous storm in the solar system. But it's not just any storm. This is a hurricane that could swallow Earth whole. It has been raging for centuries, perhaps longer than any human has ever looked at the sky through a lens. The Great Red Spot is an icon. It's also a mystery. How did it form? Why is it red? Why has it lasted so long? And recently, scientists have noticed something troubling. It's shrinking. Is the eternal storm finally dying? Today, we're going to dive into the Great Red Spot, its history, its physics, and what its future might tell us about Jupiter itself. A spot that watched history unfold. The Great Red Spot has been observed for centuries. The first definitive drawing of a spot on Jupiter is often attributed to Robert Hooke in 1664. Giovanni Cassini, the same astronomer who studied Saturn's rings, described a permanent spot on Jupiter in 1665 and observed it for decades. But there's a gap in observations. For over a century, the spot seemed to disappear or become intermittent. The continuous record of the Great Red Spot, as we know it today, began in the 1830s. Was it the same storm? Possibly, but not certainly. Some historians think the original spot faded and a new one formed. Others argue it's been the same anticyclone for over 350 years. What's clear is that since we started photographing Jupiter from Earth and spacecraft, the Great Red Spot has been a constant feature. It has watched humanity go from Galileo to the James Webb Space Telescope, and it hasn't changed much until recently. A storm that swallows worlds. Let's talk about scale. The Great Red Spot is enormous. At its peak in the late 19th century, it was measured at about 40,000 kilometers across, wide enough to fit 3 Earths side by side. In 1979, when Voyager 1 and 2 flew by, the spot was roughly 2 Earths wide. Today, it's shrunk to about 1 Earth across. But even now, it's still massive. The winds at its outer edges scream at speeds up to 430 kilometers per hour or 270 miles per hour, far faster than any hurricane on Earth. And the storm is tall. It extends about 200 to 500 kilometers above the surrounding clouds, creating a towering structure that even amateur telescopes can detect as a slight bulge in Jupiter's cloud tops. To get a sense of the scale, Earth's largest hurricanes are a few hundred kilometers across. The Great Red Spot could contain the entire planet Earth with room to spare. An anticyclone that never ends. The Great Red Spot is an anticyclone, a high-pressure system that rotates counterclockwise in Jupiter's southern hemisphere. On Earth, anticyclones are typically associated with calm weather. But on Jupiter, this anticyclone is anything but calm. It's a chaotic, turbulent vortex that has somehow maintained its coherence for centuries. How does it last so long? On Earth, storms die when they lose their energy source or when they encounter land. Jupiter has no land, and its atmosphere is deep. The storm draws energy from Jupiter's internal heat and from the sheer dynamics of the planet's fast rotation. It's essentially a self-sustaining atmospheric structure, confined between powerful jet streams to the north and south that keep it locked in place. But the jet streams are also part of the reason it's shrinking. As the storm changes, it interacts with these jet streams in complex ways. Computer models suggest that the Great Red Spot is essentially a giant, stable vortex that could persist for centuries more, or it could dissipate if it shrinks enough to lose its grip on the jets. Why is it red? The Great Red Spot isn't always red. Its color varies over time, from brick red to pale salmon to almost white. The exact cause of the redness has been debated for decades. The leading theory involves complex chemical reactions high in Jupiter's atmosphere. Sunlight breaks apart ammonia and methane, creating compounds like acetylene and other hydrocarbons. These compounds can combine with sulfur and phosphorus-bearing molecules drawn up from deeper layers. The result is a reddish chromophore, a substance that absorbs blue light and reflects red. The storm's powerful updrafts may dredge up these chemicals from below, making the spot redder. When the updrafts weaken, the color fades. Interestingly, recent observations from Juno and Hubble show that the Great Red Spot's core has become less red in recent years, while the surrounding color has turned more reddish. The storm is changing in more ways than just size. A storm in decline? One of the most striking trends is the shrinking. Since the 1970s, the Great Red Spot has been getting smaller. Not just a little, dramatically. It has gone from about 2 Earths wide to about 1 Earth wide, and the rate of shrinkage seems to have accelerated in recent decades. Some scientists predict that within a decade or two, the Great Red Spot could become circular and then possibly break apart or fade away. But here's the twist. While it's getting smaller, the wind speeds near its edge have actually increased. It's as if the storm is tightening, spinning faster as it contracts. This is reminiscent of an ice skater pulling in their arms, conservation of angular momentum. So the storm is not necessarily weakening, it's just becoming more compact. Will it disappear? No one knows. Some atmospheric models suggest it could stabilize at a smaller size, perhaps like the smaller, long-lived white ovals on Jupiter. Others think it could be gone within a human lifetime. The only way to know is to keep watching. Peering beneath the clouds. NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, has given us unprecedented insights into the Great Red Spot. Juno carries instruments that can see through the clouds using microwave radiometry to probe the storm's depth. And what it found was surprising. The Great Red Spot is not just a surface phenomenon. It's a deep-rooted structure extending at least 300 to 500 kilometers into Jupiter's atmosphere. That depth explains why it's so stable. On Earth, hurricanes are shallow. They only go down to the ocean surface. Jupiter's storms are anchored deep in the planet's interior, where they draw energy from the planet's internal heat. Juno also found that the Great Red Spot's roots are warmer than the surrounding atmosphere, which helps drive the convection that sustains it. The spacecraft has also captured stunning close-ups of the storm, revealing swirling filaments, turbulent eddies, and the complex structure of its edges. These images have allowed scientists to create detailed models of how the storm interacts with Jupiter's jet streams and smaller vortices. Will it ever die? The Great Red Spot has been a fixture of Jupiter for centuries, but nothing lasts forever. The question is, will it vanish? And if so, when? There are precedents. In the 1990s and 2000s, Jupiter had 3 large white ovals, anticyclones that formed in the 1930s from a larger storm. 2 of them merged, and eventually, the resulting oval disappeared. The Great Red Spot could follow a similar path. If it continues to shrink, it may eventually be torn apart by Jupiter's powerful jet streams. Alternatively, it could stabilize as a smaller but persistent vortex. Given that it's been shrinking for over a century, it's possible that we are witnessing its final decades. But it's also possible that it will remain in a smaller state for another 300 years. What makes the Great Red Spot so fascinating is that it's a living laboratory. It teaches us about fluid dynamics, atmospheric physics, and the behavior of rotating systems. Whether it dies or not, it will continue to challenge our understanding of planetary weather. Watching the eternal storm. The Great Red Spot is more than just a feature on a distant planet. It's a symbol of the solar system's dynamic nature. It has been there for as long as we've been looking, and it will likely be there for generations to come, though perhaps in a different form. Every time we look at Jupiter, we're looking at a storm that has outlasted empires, wars, and entire civilizations. And we're lucky to be living in an era where we can watch it change, study it up close with spacecraft, and build models that explain its behavior. The Great Red Spot may one day fade, but its legacy will remain, a reminder that even the most permanent-seeming things in the universe are temporary. What do you think? Will the Great Red Spot disappear in our lifetime, or will it outlast us all? Let me know in the comments. Thanks for watching Daily Dose of Space. Stay curious, and I'll see you tomorrow.